Hey, welcome to lesson 8 of learning to program computers with Scratch. Des is not here today, so that's why we're doing a screen recording. This is a live lesson recording, so there may be some pauses and other stuff happening. So let's get started. Okay, today's agenda, we're going to learn how to get input from a user. Alright, I think we did tackle that a bit in the last lesson. We're going to explore relational operators, so that's greater than, less than, equal to, that kind of stuff. We're going to examine modulus and join blocks. Modulus is a mathematical function. Are you familiar with that? It's basically the remainder of a division.
Okay.
So if you say 10 modulus 5, the answer is 0 because there is no remainder. But if you said 9 modulus 2, the answer would be 1 because it's remainder 1. And the join block is what we use for joining blocks of text together, which is quite useful. Then we're going to cover decision structures, which are also called if-then-else blocks. We're going to learn about these 3 blocks on the right here, which are your logical operators and, or not. Have you done any Boolean stuff in your
I think we've done a lot of probability that uses those.
Alright, okay. And then we're going to look at lists, which are basically an extension of variables, multi-valued variables, which are quite important. And in general computer programming, they come in all shapes and flavors, but Scratch only has one. Alright, so last week we did this exercise where we used the ask and wait block to get input from a user. The value of the input that they give is automatically stored in a built-in variable called answer. Alright, every time you ask something, the answer, the input that the user gives gets put into the answer block. If you have multiple ask and wait blocks, you need to then have a shadow variable, so another variable where you store the value, otherwise it'll get overwritten every time. Alright, this is the exercise I left last week, or last lesson, for you guys to do. Should we go through it quickly? Give it a shot. Okay, so we're going to have 2 sprites in our program. We've got a cat and a polar bear, and we're going to ask them to ask each other their names and greet each other by their names. Okay, so it's similar to a conversation exercise we did a while back, but there we used a timer to time the interaction, which doesn't really scale that well, because depending on how much they say, it might take shorter or longer. Okay, I've given a list of blocks here that we can use. The when green flag click block, the ask and wait block, the say block, the join block. Did we cover the join block before?
Yeah, we did.
Yeah, okay. The broadcast block and the when I receive block. We're basically using the broadcast block to manage the communication here. Everything else is just the normal plumbing stuff. So if you have a look at the screenshots, the cat asks the polar bear, "What's your name?" He then says, "My name is Bob." The cat says, "Hello, Bob." And then the polar bear reciprocates, asking the cat what its name is. So if we jump into our Scratch editor, okay, first step is obviously to add another sprite. So we go and find a sprite. You can use the bear, but you can use anything you want. Okay, and we've got our 2 characters. So on green flag clicked, we're going to start off with our cat. The cat is going to ask the bear, "What is your name?" Okay, and then we are going to put the variable, create a variable, call it bear name. And we are going to set bear name equal to the answer. Actually, no, this only works if you have user input. We don't have any user input here because the program is running itself, so you can think of it as 2 little robots. Okay, so we are going to use the normal say block, and we are going to say what is your name? Okay, and then we are going to broadcast an event. And we're going to call that event new message, ask their name. Can be whatever you like. They're just handles for you to know what they're about. So we're asking the bear what his name is, then we're going to broadcast ask bear name, then we go to our bear block, and we're not having an on green flag click because he's not starting the conversation, but we're going to say when I receive ask bear name, we are going to say box block, say my name is Baloo, or any other name you might want, and then we're going to ask the cat what is your name, and then we're going to say what is your name, and then we're going to do another broadcast but with a different message, and we're going to call this one ask cat name. Alright, and then we go back to our cat sprite and we go and say when I receive ask cat name, alright, we go and say hello Baloo, my name is Tom. Okay, and if we run our program and get rid of that variable we had, we'll just, okay, so the cat says what is your name, bear says my name is Baloo, what is your name, cat says hello Baloo, my name is Tom. Okay, now this is a bit of a cheat because I did ask you to use the join block, and the reason is because the presumption is the cat doesn't know what the bear's name is. So to get around that, we could say on our bear block, sorry, our bear sprite, we could have our bear name variable, and we could say set bear name to sorry, let's do it like this. Set bear name to Baloo, and then instead of saying my name is Baloo, we go and use our join blocks, and we say my name is, and then we put the variable in there. Okay, and then if we jump back to the cat sprite, we say hello and use our join block again. Okay, and we get the data out of our variable again. Okay, and that pretty much does the same thing, but now we're just putting the value in variables and not hard coding it in the text. Okay, so that was a quick example to use a bunch of stuff that we have covered to date. Alright, so some new stuff for today. Relational operators, you must probably covered this all in maths already. So we've got our greater than, our less than, and our equals to. Okay, in normal maths you also get your greater than and equal to, your less than and equal to. Okay, I will cover two techniques of how to achieve the same thing, but for the moment these are the only three blocks that we have. Alright, all three of these blocks are the squashed hexagon type, so that means their output is going to be Boolean, true, false. Alright, so if price is our variable, we're checking to see if it's greater than 2000. Here we're checking to see if it's less than 2000, and here we're checking to see if it's equal to 2000. These comparisons are used all the time in computer programming. You're always checking if something is bigger than, equal to, or less than. When it comes to numbers, when it comes to just text, you're always checking if something is equal to or not equal to, either in whole or in part. Okay, and we'll cover to the in part thing in a later lesson. Alright, so if we look at some examples, we've got two variables, x and y, that we're using to contain our values. And here on the right, we've said x is equal to 5 and y is equal to 10. So we have a third variable called z, and we're setting the value of that variable to our operator, or the output of our operators. So is 5 less than 10? The answer is true. So z will have a value of true. Is 5 greater than 10? No. So z will be equal to false. Is 5 equal to 10? Answer is no. So variable z will have a value of false. And is 5 equal to 5? So now we're not using the y value, we're comparing it to what we call a static value. And it is equal to 5, so z will be equal to true. So we're storing the answer, if you can think of it as an equation, in our third variable, which is z. Now, another way we do it is we have state variables. Okay, if you think of a little computer game where you're flying around shooting stuff and you've got a set amount of bullets. When you run out of bullets, you can't shoot anymore. So you could have a count of your bullets in the can fire, and when that, a count of bullets somewhere else, and then you can have a check like we do here, and we say if count of bullets equals 0, then we set our can fire value to 0 or 1. Okay, and we can check that to see in the game if you can still fire. Okay, doing this is what we call using our variables as a flag. Okay, a flag indicates a condition. Okay, and usually it's a true or false thing. Any questions? Nope. Okay. Alright, decision structures. Okay, these are very important in computer programming because unless you can branch, unless you can take two different paths or multiple different paths, you can't do much in computer programming. Okay, so this is where our condition comes in, the green block at the top here. That's the purpose of going through all of this stuff, is to have something that we can use as ammunition in our decision structure. So the basic one is just the if structure. So we have a condition which we check. Only if that condition is true do we do the other commands inside the if structure. If it's false, we skip over all those commands and we jump straight to command M. These are not real blocks, it's just pseudo stuff to illustrate a concept. This thing on the right here is called a flowchart. Have you ever used that before? So you basically have your arrow coming in the top into this diamond block. It has a test condition which has two possible outputs. If it's true, it goes to the yes leg and it executes command 1 through n. If it's false, it goes through the no block and executes command m, effectively jumping over these. Alright. Okay, here is a simple example of using the if block. Okay, so we start off when green flag clicked, set x to 0, y to 0, so we put our point in the middle of the screen, point in direction 45, so up to northwest, I guess it would be. And then we've got a forever block, so the program is going to carry on looping all the time. And then we move 5 steps, and if x position is greater than 0, then we change the color effect by 25. If it's not, then we do nothing. It stays exactly what it is. And then if on edge bounce. So only while it is moving in the positive side, so the right side of the stage, does the color change every time. Otherwise, it does nothing. It stays what it was. And if it moves to the left of the origin, it also does nothing. Okay, does that make sense? So we don't need to go through it to illustrate it. Okay, good. Alright, so now this is the expanded version of the if block. It's the if then else block. Because very often you will want to do one of two things, not just one thing. Okay? So it works exactly the same as the if then block, except now has an alternate path. So if we come in on our condition in the top here, we check our test condition. Previously we only covered the yes leg. So if the condition was true, we go down the yes leg and then pop out at the bottom. Now, if the condition is not true, we go down the no leg and then again pop out at the bottom. Okay. Alright, there are other kinds of decision structures that you get in other programming language. I think Scratch does have a while block as well, which we also use. There are 2 or 3 different kinds, but this is the one that gets used as your bread and butter. Alright, so here we have an example of a if then else block. Okay, we're not doing a green flag clicked at the top, we're doing a when space key pressed. We ask the user to enter a positive number and wait. Then we do a check. Okay, what do you think that answer mod 2 equals 0 does? Without reading that.
Checks if it's if the remainder of the number is 0, then it's an even number.
Yeah, okay. So if answer mod 2 equals 0, so if you divide a number by 2 and there's no remainder, then the answer is even. If it does have a remainder, then the answer is obviously odd. There's only 2 possible outcomes. Okay. Alright, now nesting. Okay, also an important thing when it comes to using your if-then blocks. Okay, we don't check if the answer is 0, because 0 is not odd or even, it's just 0. So at the bottom here, below the red rectangle, we've got what we had before, but we've now encapsulated it in the else part of an if-then else block. And in the top of it, we put if the answer equals 0, then we say the answer is either positive or odd or even. And that off should be an odd. Okay, so spelling mistake there. So that is how you can do nesting, and you can do multiple levels of nesting. Okay, it can get quite tedious at times. Okay, you can end up with 10 or 11 levels, so much so that your code doesn't fit onto the screen and you're scrolling and trying to figure out what belongs to what. Most modern development environments make that easy for you. They will highlight matching if-then, else's, and whatnot. But we'll get to that later. Okay, there is a cool demo on your flash drive called linefollow.sp2, which covers this. So let's go have a look at that quickly. Okay. Line follower. There we go. Okay, so this is basically a little bit of robotics. You've got a cat that's sitting on a track, and it is basically going to drive itself around the track. The track can be any shape as long as it's a closed track. All it's doing, if you look at your cat, so if we go and have a look at the costume of the cat, you'll see that its ears are different colors and its nose is a different color as well, and it's using that as a sensor to figure out where it is. If we have a look at the code, okay, just looking over here, if the color pink is touching black, then we move 2 steps, so we know we're on the line. Okay, if the color yellow, so the left ear, is touching black, then we know that it's drifting over to the right. Okay, so we turn 5 degrees counterclockwise and then move half a step. So we try and inch our way back onto the course. Else, if the green, so the left or right ear is coloring, then we turn 5 degrees in the opposite direction, also move half a step. Okay. Otherwise, we move half a step without doing any turning, and if we're on the edge, we bounce. So if we give this a shot and we run it to see how good our cat is, okay, you can see it's doing the auto-correction thing. Okay, went a bit off course there around the corner, goes a bit off course around the sharp corners, but it still manages to follow the line pretty well. Okay, this is a very basic algorithm, but you can see it does achieve an acceptable result. So when you read about all those self-driving cars, they're kind of doing something like this, just with a lot more inputs. Okay.
I know when I was at Tux, they were speaking about the final year electronic engineering product, and it was something with the car.
Yeah.
And had to follow covers and
Yeah.
all on there.
Well, Tesla, I don't know if you've heard of Tesla. Yeah. They've just announced on Wednesday this week that all of their vehicles currently in production and future models will all have self-driving capabilities. They showed a video where a guy basically sat in the car at his house and drove him to work. He got out at the entrance. The car circled the parking lot looking for a space, didn't find one, went around the corner, parked itself there, and when he was finished, it came and picked him up at the front door. That's crazy stuff.
I know that Volvo's also working the XC90 for self-driving.
Yeah, a lot of the manufacturers, the BMWs, the Audis, the Volvos, yeah. Okay, so that's if then else. Like I say, you can nest them and it can get quite hairy. So we are going to cover something a bit later which makes it a little bit more compact, but we'll get to that just now. Okay, and that's exactly what I'm talking about here. So we have Boolean operators or relational operators, and there are three of them. There's the and, the or, and the not. Okay, so we're going to examine it from doing the exercise from one point of view with what we know, and then we're going to simplify it down using the and, or, and not blocks. Okay, so basically we are asking the user to enter a number. We're then checking if it's 0 and it's less than 10 and it's not divisible by 2, so it's an odd number, or if it's a prime number. So if you have a look at the code here on the right, we have 1, 2, 3, 4 if then or if then else blocks. Okay, the first one checks if it's greater than 0. The second one checks if it's less than 0. If it's false at any point, it jumps out the program. Okay, because remember, we only continue if the condition is true. Then we do answer mod 2 equals 0. That will say if it's the even number, but we're not looking for even numbers. So we've chosen to leave the true part empty on our if then else, and we hit the false part. So if even equals true, then we don't care. If even equals false, then we do care. Then we found a valid candidate for our check. The second one is to check if it's a prime number. So we've just added a custom block in here. The inner workings we don't need to go into, but we pass our answer in, and it sends back a value via this variable called isPrime as to whether or not the value the user chose is prime. If it's equal to 1, so it is prime, then we say bingo as well. Okay, so you can see there's a lot of code here, mainly because we're doing one thing at a time and we're nesting a whole lot to get this answer out. So if you look at the text on the left, there's 1, 2, 3, 4, 5 lines. If you look here, 1, 2, 3, 4, 5, 6, 7, 8, 9, there's a whole lot more lines. Okay, we can simplify it greatly by combining our checks, okay, using our and, or, and not blocks. So if we do the same thing, we can reduce it to this. Okay, so we've taken all our questions that we wanted answered and we've combined them. We've said the answer greater than 0 and answer less than 10 we joined with the AND block. Then we also checked to see if it was odd. Okay, so the easiest way to do that is to check if it's even. Answer mod 2 equals 0, and then we not the output, so we negate it, we invert it. So if it's answer mod 2 equals 0 is true, we want it to actually be false, so even. But remember, we only move forward when things are true, so if we make a false value true by using a not, then we'll move forward. Then we use an OR block at the end to do our prime check. Okay, and that basically achieves everything we needed in one line. Okay, again, these can get very tricky. Remember, your little blocks, the ends of them basically represent parentheses or round brackets. You can land up with 3 or 4 or 5 brackets deep, and it can get very tricky to figure out where you're missing a bracket, where you have too many brackets. But that's something that comes with experience when you do programming. So yeah, any questions so far? No. Alright. Okay, so let's go have a look at our operators in more detail. Okay, we've got three of them. We've got the AND, OR, and NOT. Okay, the AND and OR both have two inputs. The NOT only has one input. Okay, if we look at our example here, we've got our AND block with the X and Y input. Okay, we've got three columns here, the X value, the Y value, and the output of our AND operator. With the AND operator, the only way you get a true value out is if both inputs are true. Okay, so if you look X equals 0 or true, Y equals true, your output will be true. For any other combination of values, your output is always false. Okay. If we look at our OR operator,
One of them needs to be true.
yes, only one of them needs to be true. So the only way you get a false out of an OR operator is if both values are false. Okay. And then we've got our NOT operator. Whatever the input value is, it flips it over to the opposite one. So if you put a true in, you get a false out. If you put a false in, you get a true out. Okay. Now typically you wouldn't flip a value just because you wanted to flip a value. You would flip it because it's easier than trying to do the calculation some other way. So if you know how to find primes really easily, and it's trying to figure out if you don't have a prime, rather check if it's a prime and flip the value to find out if it's not a prime. Okay, so if we look at our example again, we can see here we combined our first two questions in the red block with the AND operator to get whether or not it falls between 0 and 10. Then we did our check to see if the answer was odd or even, and we used the NOT block in the black block in the middle. Then we combined that with our is prime check using the OR block, and then we combined the purple block and the red block with the AND block. Okay. Now, just like with maths, where you've got your BODMAS rules, addition, subtraction, etc., the same thing applies with the relational operators. You need to make sure you put them together in the right way to make sure that the answer is going to be the right thing at the end of the day. So just because you have everything on the same line doesn't mean it's going to work. You need to make sure you group them logically to make sure that our answer is going to be the right one. Okay, so like I said earlier in the lesson, we don't have a greater than and equal to or less than and equal to sign in Scratch, but we can achieve that through two different ways. Are you familiar with this notation, the open dot, the closed dot on the number line? Okay, so if we wrote x greater than or equal to 10 on a number line, we would do closed dot over the 10 to indicate that it's included, and then the arrow to the right says everything greater than 10 as well. So we can do that in two steps. If we look at the right, we can say x greater than 10, so we have an open circle over the 10 showing it's not included, at 10.00001 is, and then our arrow off to the right indicating everything greater, and then we have a closed dot only on the 10 with no arrows indicating the 10 is included. So we basically have x greater than 10 or x equal to 10, and that gives us the x greater than or equal to 10, which you can see at the bottom there. The other way to do it is to do the opposite and just negate the output. So x greater than or equal to 10, the opposite would be x less than 10. Okay, so x less than 10, open circle on 10, everything to the left. So if we not that, we land up with x greater than or equal to 10 effectively. Okay, so two different ways of achieving the same result using either our OR block or our NOT block. Okay, and if you do go into electrical engineering, they will do logic gates, and you will start hating logic algebra because I don't know if you've done trig reduction stuff in the maths you've done, where you sine cubed x cos blah blah blah, you reduce it down, you'll end up doing the same stuff with logic, which can get quite hairy. Alright, so now we're going to do an exercise, okay? Using our newfound knowledge, we're going to enter a number between 10 and 90, call it x. So everything here that's underlined, x, computer, and user, are all variables. So you're going to have to create 3 variables. So you're going to enter a number between 10 and 90, call it x. The computer gets to pick a number, random number between x and 100. You pick a number between 0 and x, and then you do these 3 formulas below, or checks, to see who has the greater value. Okay, who managed to get the biggest difference between the initial value and the second value. Okay, so fire away. Can I get you some tea or coffee or something? Okay.
Well, I did this with these blocks and then the and block.
Yeah, I would start off with the first 3, so getting all your values, and then doing the bottom 3 once you have your values. So go create your variables, your x, your computer, and your user. Okay, so you're going to obviously start off with a when green flag clicked, and then you're going to ask the user to enter a number between 10 and 90 and store it in your x variable.
Okay, how do we put in these numbers then?
Okay.
Like the x between 10 and 90, we use these blocks.
Okay, so first of all, you're going to go to your sensing blocks,
Yeah.
and you're going to say ask.
Okay.
Yeah, so third or fourth block, fifth block from the top. And here you can just hard code 10 and 90, so enter a number between 10 and 90. Okay, then we're going to store the value that the user provides in our x variable. So you can drag that set x to 0 to below your block, and then go for your answer block and put it in. Great. Okay. Now the computer needs to pick a number between x and 100. So the next one will be set computer to, and then your usual random. Yeah.
That's the block I was looking for earlier.
Yeah.
And then this will be or ask again.
a join block because
Okay,
you have to use your x value, which you don't know what it is, in your question.
How do you change what the output of this answer is?
You mean what it's going to show you on screen?
No, like what that block will be.
It automatically gets saved when so that what your question will come up on screen. There'll be something where they type the answer.
So it overrides this answer.
Yes,
That's fine.
yes.
Okay.
Because you've already stored the answer in
Okay.
your x value.
Okay.
Yes.
Okay.
So it doesn't matter that it gets overridden.
Okay.
Okay, you didn't actually need two joins there. But
Okay.
yeah,
Still works, right?
it'll still work. Yeah. Yeah.
Should I brought
Nope, don't need any broadcasting. You just need 3 if
so I
then
just add this
statements.
here.
Yeah.
Okay. Only if then.
Yeah, you can do it many different ways. The simplest one is if thens. Yeah, and then you need to do your x minus user and your computer minus x 3 times. So just create one of each and then just duplicate it twice.
Is what I do.
Frustration. Doesn't really matter on the order.
No, I'm just gonna say computer ones order. So you don't get to see what's, oh, there's the computer's number.
Yeah.
Okay.
Yeah. Okay, so a couple of problems here. It's kind of like tic-tac-toe. If you know what the equations are, you can always win. What would your strategy be to always win?
You always pick something less than the answer that you input.
Well, you kind of have to anyway.
Oh, why'd you always win then?
Okay, so you are supposed to put in a value between 10 and 90. Okay, so you would want to make the value as big as possible to make sure that the computer didn't have a big range to choose from. So if you picked, say, 80, okay, the computer could then only pick a number between 80 and 100. So the maximum difference it could get is 20, whereas you could get a maximum of 80. All right. So it's not an incredibly challenging game to win. The second point is there's no validation here. Okay. Do you know what validation means in a computer sense? Okay. Validation means checking. If the computer asks you to do something and you don't do what it asks you to do, there's no checks here to see that you did what it asked you to do. So it said please enter between and 90, but if you put in 500, it would just carry on trucking and work out whatever it wanted to. Excuse me. We are going to cover validation in a later lesson, but it's just important to highlight it here, that even though it asks you something, you're under no obligation to do what it asks you to do. Okay. Alright, lists. Okay. Lists, like I said, are multi-valued variables. Okay. If you had to go and create a program which let the user enter as many colors as they wanted to, and you had to store these, you would have to create a variable for each and every color they entered, which can get very tedious because you'd have to do it manually first of all. Second of all, you would have to come up with a unique name for every variable, okay, and you would get tired of that as well. So what we do is we have a thing called lists, which is a multi-value variable, okay, and allows you to store more than one item in a list. And this is usually unbounded. If you want to store bazillion, you might run out of computer memory, but computers are pretty good at storing lots of stuff. So for general purposes, you can store as much stuff as you need to. Alright, so just like variables, lists have a name. So in this example we've got here, we've got a day list, and then we've got items in our day list, Sunday, Monday, Tuesday, etc. Okay, the order in which you insert the item leads to the number that that item has in the list. So it starts at 1 and it carries on to however big your list is. Okay. Starting at 1 is kind of significant because in most computer languages your lists start at 0. Okay. So if you've got a list that's 10 items long, your numbers or indexes for those items will be 0, 1 through 9. Okay. And that's one of the computer jokes that computer people are always bad at naming stuff because you're dealing with lots of variables and you have to come up with creative names for them, or functions or program names or whatever, and we always have off by 1 errors because we always forget that it started at 0. Okay, it will become the bane of your existence if you become a programmer someday. But for sanity's sake, Scratch decided to start at 1, so everything works out just dandy. Okay, so to create a list, we do it pretty much the same as we do with variables. We go to our data palette, bottom left-hand corner, the orange one, and instead of clicking on make a variable, we click on make a list. Okay, so you can file new there and we can start off fresh. So if you click on make a list, you can go and give it a name, call it day list. Okay, just like normal variables, it also has a scope. So it can be for all sprites or for the sprite only. Remember, if it's for this sprite only, other sprites can still read it, but they can't modify it. Okay. Alright, so there's a whole bunch of new blocks that become available for lists, just as we had them for sprites. Okay, if you start off at the top, you have your monitor. Okay, if it's got a little checkbox next to it, it'll show the monitor on your stage. If you uncheck it, then it'll hide it. You can also do that programmatically using the show list and hide list blocks at the bottom. Okay, the monitor looks a bit different to a normal variable monitor, which had 3 different modes that you could view it in. The list doesn't have 3 different modes, but it does show you a lot more information. See down the left hand side, as you add items, it'll show you the index for those items. In the bottom left, there is a plus sign, okay, which allows you to manually add items to the list. It also shows you a length at the bottom, showing you how long your list is. Reason being, your list might be very long and it'll scroll, so you won't be able to see easily what the last item is. And you can also resize your list using the little drag handle in the bottom right hand corner. Okay, but coming back to the blocks, we've got add thing to your list. Alright, that just adds another element to your list. It always adds it at the end unless you ask it to do otherwise, which we'll get to. Delete, there you specify which one to delete. So if you've got 3 items in your list, A, B, C, and you say delete 2, it will delete B, and you'll have A and C left in your list. You can also insert a thing at a specific position. So if you've got A, B, C, and you say insert X at 2, you will end up with A, X, B, C. We've got replace. So replace is kind of like a delete and insert, but it does it for you in one step. So you replace the item with the value that you provide with another one. So if we've got ABC and you say replace 2 with Y, we'll end up with AYC. Okay, then all of these blocks, except for the first one that we've covered so far, have the dents and the bumps. So those are code blocks that you can put into your program. The next 3 blocks don't have those bumps, so you can't use them directly in your code. You have to use them as inputs to other blocks. So if you want to get the value of an item in your list at a particular position, you say item, give the position number of the list. Remember, you can have multiple lists, like you can have multiple variables. That's why there's that little black triangle indicating you can drop down, and then it will return the value at that position. You can also get the length, so you don't have to look at the variable monitor to see how many items. You can get the length, and that is very useful when you are looping through your list to get all the values out. You can use that to set how many times your loop runs to make sure you get every value. And then we've also got a check to see if your list contains a particular item. Okay. If you didn't have this, you would have to loop through every item in your list, go see if it's equal to the one you're looking for, and then say, yes, I've got it. But this short circuits all of that by doing it internally, and it just, you say what list to look in for what thing, and it'll return a true or false, or 1, 0. Okay, so those are all the blocks. Any questions? No. Okay. Alright, so let's start off by adding some items manually. So we've got our day list, so we can add 7 items. So you can just click on your plus sign in the bottom left hand corner of your variable monitor, and every time you click it adds a new item, and then you can just type in the days of the week. There you go. See, when you have focus in the block, there's a little gray circle with the X on the far right. That is if you want to delete an item. Okay. Obviously, if you want to make your monitor bigger to see everything, you can resize it. If you click in a cell or on an item, it then goes into edit mode, and you can go and modify it. Okay, so that's how we do stuff manually, but we're not going to do that. We're going to do it using code. Okay, so we can go and create another list, call it grocery. Okay. Okay, and then on green flag clicked. And we're going to add apple, orange, and mango. So if we add thing to grocery, just going to repeat that 3 times, yeah. Okay, and if we run our program, we should see it add the 3 items. If we run our program again, what happens? It adds them again. So your list persists across running of your program. So every time you run it, if you're adding stuff, it's going to add the stuff again. So if that's not the behavior we wanted, the first thing we would do is clear our list. Okay. So if you go and delete, okay, you can do it that way. Or if you click on your little arrow next to the 1, you'll see there is an all option. And you would put that just under your green flag clicked to clear everything out before you get started. This is something we've discussed before. It's called initializing your variables. Okay, you make it equal to a known value, or you clean it out to make sure that it starts off in a clean state. Alright, so now we are going to delete. So we need another delete block. So we're going to delete item 2. Yeah, there we go. Alright. Okay, you can type it in. Okay. The other ones are just shortcuts there. So just click on it again so you get the list. Just on the little black triangle. Okay, 1 is obviously the first item. Last is the last item. Now the reason why that's useful is because if you have 3 items and you delete the last one, then you've got 2. If you want to delete the last one, you have to know that you've got 2. So you could use the length block, which shows you how long your list is, and always delete length. Okay, but they've already shortcutted it for you, and just you choose the last one, and I'll carry on deleting the last one. Alright, so we've deleted number 2, and now we're going to add lemon to our list. Okay, add our lemon. Okie. And if we run it, this should now say apple, mango, lemon, because we deleted our orange and we added lemon to the end. Okay, now this is using a different list with phone numbers and names, but we'll just carry on with our fruit, and we're going to do our replace. So we'll add a replace block at the bottom, and we can say replace item 3 with peach. And then we're going to do an insert. Okay, yeah, let's say insert banana at number 2. Okay, now before running it, what do you think our list? You just can't resist that drop down. What do you think our list is going to be?
Apple, mango.
Okay, so let's do it manually. Okay. So our list starts off with apple, then orange, and then mango. Okay, then what do we do?
Delete 2.
So then we go and delete orange, and orange disappears. And then what do we do?
Add lemon.
We add lemon on. Then what do we do?
We take lemon off and put peach.
Where are we now? Replace item 3 with peach. So I'm going to take lemon away and put peach in, and then we're going to insert banana at number 2. So that's what we should have. And we run it. Is that what we get? Apple, banana, mango, peach. Okay, so manipulating lists is quite important. You'll see maybe in a later lesson we'll cover sorting of lists, which is also useful. Most modern languages have built-in sorting, but you need to know how sorting works to begin with. And obviously inserting and removing items is important as well. And then if you look at the big picture, this is really a lot how a database works. I don't know if you're familiar with databases. Okay.
I do have an idea.
Alright, so you've got a bank, it's got a whole bunch of customers, they've all got account numbers. So you need to keep a record of that. You need to keep their address, you need to keep every transaction they make, and all of this stuff has to be sorted in a database. They usually have multiple databases, and in a database you have what they call a table. A table is analogous to our list, but where our lists are what we call one-dimensional, so they can store one value multiple times. A table can store multiple values multiple times. So it's literally a table, X and Y, rows and columns, and yeah, there's a whole different language just dedicated to working with databases. It's called SQL, which is Structured Query Language.
Yeah, I know my mom's talking about it.
Yeah, so if you want, we can maybe dive into that sometime as well. Okay, so that's our lists. Alright, so going back to our day list, you can kill that what we've got there. No, we've already got a day list. I'm saying you can get rid of that code. Yeah. Okay, we are going to do a little loop to go through our list to get the program to read us the dates or the days of the week. So on green flag clicked, we have a variable called pos, which is short for position, which is where we are in the current list. Then we repeat 7 times because there are 7 days in the week, and then we use our say block to go and find item position of day list, and we say it for 1 second, and then we increase our pos by 1 and carry on looping. Okay, now what happens if we didn't know how many items were in our list? We didn't know there were 7 days in a week. What would we do?
You would put in an operator block.
Which would do what?
With the length of grocery, and then you do everything else.
Okay. You wouldn't need an operator block because we just need to know how many items.
So you just
So you would just put length in there. Okay, so do this, but instead of putting 7 as a hard-coded value, rather use the length block.
I'm just going to read this. Can I do it?
Yeah.
So what did you probably do?
Where it says 7,
yeah, okay.
you're going to use the length block down here.
Okay.
Okay, now why is your pos value ending on 8?
Because it still goes up by 1 after. Yeah, because it goes up, yeah. It still increases after you've done.
So
it just doesn't repeat.
Yes, so it started off at 1, the loop ran 7 times, and the end of the 7th time it didn't carry on, but it had already been incremented. So the other option we could have done is we could have said started at 0, but then instead of incrementing it at the end, you increment it at the beginning. and then your pos would end off at 7 as well. Okay. Right, so there are some caveats when it comes to using lists that you need to be aware of. Okay, if you enter an index which is higher than your list length, then it's not going to return anything. Other programming languages not so forgiving, that will give you an error. If you enter a non-integer value in your list or item that you need, it'll ignore the decimal part and return the integer. So 1.9 will become 1, 3.7 will become 3. And then it will go and return the value. If there is one for it, if it's still bigger than your list length, it'll return nothing. If you try and insert a value beyond the end of your list, okay, so you've got a list of 7, you try and insert a position 10, it'll just ignore that. Okay, if you insert it at the end of the list, so we've got 7 days, we insert something at 8, it will insert it. It's effectively the same as adding a new item to the list. And if you try and delete something that's not in the list, it won't delete it, there's nothing it'll do. All of these things will give errors in a normal programming language, which you'll have to fix or handle in your code. Scratch, being for kids, very forgiving, doesn't let you hurt yourself. Okay, think of it as safety scissors for programming. Alright, so now we're going to do another exercise for you. Okay, we are going to get it to draw some random lines. Okay, so we're going to ask the user to enter a number of random points to plot. Okay, so you're going to first off say how many points do you want to plot, and then it's going to do a loop for every one of those points, and it's going to say enter an x value for those points. Then the computer is going to go and create a corresponding y value, and then you're going to draw the line joining each of those points. Okay.
Okay.
Okay, so you will need a list of items.
So these are going to go my x and...
Yeah, so items is going to be your list. Okay. My x and computer y will be normal variables. Actually, no, I lie. Okay, we're going to have two lists. We're going to have an x and a y list. Okay?
So I must delete the variables.
Yeah. So you're going to have a list called my x and a list called computer y. Okay, those will be your two lists. Okay, then you are going to have one normal variable called items. That's going to store how many items we're going to plot. Okay, so you're going to start off your program, and you're going to ask the user how many items do you want to plot. Okay, and you're going to store the answer they give you in your items variable. Okay, now we know how many items we need, so we need to ask the user for an x value for each item. So we're going to need a loop first, unless you're assuming they're only going to want one value. And how many times we're going to loop it?
Items.
Exactly. Okay, now you can ask your question. Your x values go from minus 240 to plus 240. Okay. The other minus 240. and we need to store the answer they give us in our myx list.
Add answer.
Okay. And at the same time you're doing that, you need to get a y value, which the computer is going to choose at random. Which you can do directly after. You don't have to have a separate loop.
Okay.
One loop can handle both sets of values.
Or go to, no.
You're going to use exactly the same as you did here, but for the computer y,
Okay.
instead of answer, you're going to put your random block in. Okay, y can go minus 180 to plus 180. Okay, so now you've got your sets of x and y values. Now you need to do some drawing. Technically you wouldn't start at x0, y0.
Yeah.
You would start at the
Yeah,
first
that's
point.
what I'm gonna do. Right?
Yeah,
This
kinda.
will be just length of the items.
Yeah, I would have given you the same value.
Okay. How would you get it to the next one?
Good question. We already covered that. You need another variable.
Variable.
We called it pos last time. Boom, boom, boom. Remember that one?
Yeah. So plus 2. Item 1.
What are you trying to do? Just talk it out. Talk it out. What do you need to do? You've got a
I
list.
need to go to the next position.
You've got a list with the number of items in it.
I think I know what to do.
And you need to step through them one by one.
So then I'll put pos in there. Pos plus 1.
No.
No. Okay. So pos to 1.
Yeah. Yeah. And one more step.
Mm. And pos by 1.
You tell me.
I know.
I don't know, we'll find out. Ta-da! Well done. Okay.
Okay.
Now, I think that was the last. Oh no, we've still got a bit more. Okay. Let's just compare what I ended up with. I got fancy with blocks and whatnot. So repeat items, change number 1, ask join enter. Max value, okay, so this one asked, told you which number item you were entering. Okay, and it didn't put it at the extreme. And then go to pen color.
Yes, it's fancy. It changed the color.
Yes, okay.
Yeah.
Alright, so that was the end program. Okay, so you get to jazz yours up now, but change color on every line, and if and then alternate the thickness of the line. Okay, alternate. So one is thick, one is thin, one is thick, one is thin. You do. Because you're going to be using a modulus block.
Okay.
If that helps. So your color was right, but for alternating, you need a modulus block.
What would be with if? What would be if?
Connection to if then else. Remember that change adds to or subtracts from the current value. If you want to set it, then you need to use the set block. Okay, see what happens.
Oh, I didn't clear my list.
Oops.
Is this one right?
You didn't clear stage either.
And yeah, okay, that's fine. I'm going to change this to modulus.
Cool.
Yeah.
Okay, that looks pretty good. Alright, do you have any other questions?
No, I don't think so.
No.
I did enjoy this lesson though.
You did?
Yeah.
Okay, was it fast enough, pace, and all the
And
rest
it was
of
a
it?
bit more challenging. So
Okay, alright, challenge accepted. I'll come up with something interesting for you to do. There are some bigger projects which I have done in the past, which I didn't include because they can slow things down quite a lot. So yeah, I can maybe give those to you as exercises if you want to try them in the holidays.
And I'll start opening your emails.
Yeah.
Okay.
Because otherwise I'm trying to get through all the theory.
Yeah.
We've got one, maybe two more lessons, and then we're done with all the theory.
Okay.
So I can give you some stuff if you want to practice in the holidays,
Okay.
or when
Yeah.
we pick it up again next year. Okie dokie. Alright.
Okay.
Well, let's end the lesson there.